Right. Good afternoon. Um, I think after around 3 weeks, oh, I think 3 weeks, right? The 3 weeks, I think I'm meeting you. So I don't want to actually waste time. I'll just go ahead and start. So basically, if you can remember where we stopped, we stopped actually at session unit one, session number two. We were supposed to cover. But I decided not to start session number two. That means the construction and some operations, some sections related to Valtrain and that area, because today onwards you will be starting today evening. Today evening, one of the groups will be doing the presentations. So I thought it's better to do the that section after the presentation. It seems better, so I will have a better understanding how much of your knowledge, and based on that, I can actually uh, increase or reduce the sections to be covered. Anyway, so yeah, so you need to class. Wait, I'll remove this. Okay, hope every one of you can hear me. Anyway, so we'll just go ahead and start. So today our lesson is actually the fuel system. So under the fuel system, we'll be discussing about the fuels, right? Uh, sorry. So requirement of a fuel system, types of fuels and characteristics of fuels, petrol fuel system, diesel fuel system, and electronic fuel injection and common rail diesel fuel injection types. So since you have already done the practical related to this thing, this section, I think it will be easier for you guys to actually understand it. Anyway, if I give you like a brief introduction, how the module or how this unit is going to play out, how we're going to go through this module. So we'll first start with the fuels, what sort of fuels using and what are the characteristics of fuels. So then we will go to the petrol fuel system and diesel fuel system. And I believe you already have a certain idea. Uh, I know you have some idea how the diesel fuel system and petrol fuel system works, especially from your advanced level exams, advanced level knowledge. And I am planning to build on that. So what I'm going to do is I'll briefly discuss about that section, and I'll be moving into more modern sections afterwards. So my main concern today in this unit is regarding the electronic fuel injection and common rail diesel fuel injection systems. So I'll be mostly I'll be mostly spending my time on this part. I expect to spend around 2 hours just on fuel injection system, but not today. Next day, I plan to spend more time on this fuel injection systems. But the rest of the things I'll be covering today. But while I'm covering these things, especially this petrol fuel system and diesel fuel system, I'll be giving you a brief introduction or brief input or introduction to this electronic fuel injection systems. Then when we go to the next time in the next day for the electronic fuel injection systems, it will be easier for you guys to actually understand that module. So that section, that's the plan here. Okay, so we'll go ahead and start. Yeah. So first thing is first, we need to know what are the automobile fuels. So automobiles actually use different types of fuels, but whatever the fuel we use, we can actually use more than one. Petrol and diesel is the most common fuels, but there are other fuels that we can use. For example, kerosene oil also can be used as a fuel. So as I told you earlier, the automobiles became popular in the 1900s, so it's actually end of the 1800s. Near the end of 1800s, the automobiles were popular with electric motors, batteries and electric motors, because those days we didn't have this fuel. So like in the introduction of the automobile, during the introduction of automobile, these sort of liquid fuels were not available. So instead of that, we only had the charcoal, or not charcoal, actually coal. but using coal engine in a coal burning engine inside of a vehicle was not a very practical method considering the size of the vehicle. So that those days automobiles were not that popular. So the available option was actually to use uh, option was to use, sorry, one second. Yeah, option was to use electric propulsion systems or batteries and motors. But as you could have guessed, batteries and motors were actually expensive and too heavy. So because of that, most different fuel types were searching at that time. People discovered crude oil. Right, crude oil was discovered, also known as black gold. Then people understood how to actually deal with crude oil. Then they were able to find out how to take different fuels out of the crude oil. Crude oil is actually a mix of all of these hydrocarbons and all different fuels. Then by using different chemical procedures, you actually have to take separate fuels out from that. So anyway, so after this fuel became popular, people understood these are very easy to use. Then it ended up using in the automobiles, right? So having a fuel system or having a liquid fuel as the energy source for a vehicle becomes it becomes very convenient for us. As you know already, within like few minutes we can refill and we can go. Transport is very easy, cost of production is very low, and availability is very high. So because of those reasons, these became very much popular. Even until around 1970s, people were not even concerned about how much of fuel consumption is, right? Until around 1970s, nobody cares how much fuel consumption is, because the fuel or this oil was very much available. Then only this was actually, or then only these OPEC and all of these guys started because of the world wars, different political reasons. Political reasons actually pushed the world into sort of a oil shortage. That we being ended up understand, that made the people understanding that fuel consumption is a very big uh, factor. Then only the fuel consumption was reduced. Then so different. There's a big story behind that, which I'm not going to go here, because you can, if you wish, you can learn them later. Anyway, so crude oil. Then we take the crude oil. So anyway, we started using gasoline and diesel, also known as petrol and diesel, right? So basically, in any automobile fuel, right, any automobile fuel, those are actually any fuel that used in the automobile is actually a mixture of hydrocarbon. Depending on the mixture, what are the subchemicals available, subsections of chemicals available in that fuel type, right? Fuel type, that means the petrol or diesel or kerosene oil. The amount of energy produced is actually different from each other based on how the structure of that particular fuel inside, right? So chemical structure. So these everything is depend on the chemical structure. So based on that chemical structure, the operating conditions required for each fuel is different. That's why we actually have a compression ignition engine and a spark ignition engine, right? So compression ignition engine means basically a diesel engine where compression of the air fuel mixture ignite by itself, and in the diesel engine, air fuel mixture need a additional spark in order to make it make the combustion start, right? So even though these fuels having different chemical reaction, chemical structures, means they, in order to take them out, or from the crude oil, there had to be different method has to be used. The most common method or most simple method is fractionating column, the one is actually shown in your image. So what it does is, once you supply the oil into a furnace heated up to around 400 degrees, then because of these different oils have different all these evaporative temperatures. Based on the evaporative temperatures, these fuels can be actually taken out from different stages of this column. So uh, that's why it's actually mentioned at 150 Celsius we can get gasoline, but around 370 fuel oil. Fuel oil is also known as heavy oil used in the ships, mostly ships and generators. Generators means there's commercial grade generators, not the generators that we use in homes. The commercial grade generators use this heavy oil, also known as fuel oil. Right. So this was the earliest method, but because this is not economical and with the demand, since the demand increased, with the demand increase, this was found it's not economical. With that, there's few other methods were introduced, such as thermal cracking method. There are around 4 methods used, but you don't actually have to be worried about that at the moment. You just need to know the crude oil. We use crude oil, then we take diesel, kerosene, and different fuels out from the crude oil. So based on the cost of the fuel is actually depending on where we can actually get it. So since the gasoline is actually, or the petrol is taken out from the top, near to the top part of the fuel, this furnace, that's why it's actually quite a bit expensive. As if you consider the diesel is actually coming very close to the bottom of the furnace, and fuel oil or the heavy oil even below than that. So that's how we actually take the fuels. But whatever fuel type we actually take, there should be some characteristics for any fuel in order to be used in the engine, right? In order to used in a engine. So we can actually, the basic characteristic of any fuel, right? Basic characteristic of any fuel can be described in these 6 boxes. First one is actually knock rating. Knock rating means uh, during a higher compression, right? During a higher compression inside the combustion chamber, if the air fuel mixture can come by, if air fuel mixture is capable of burning or combusting without creating a violent explosions, that is good, right? So this capability is actually known as knock rating. That violent explosions are not, for us from outside, actually feels like knocking, right? So a fuel should actually have a higher knock resistant rate, right? Knocks should be resisted by the fuels. Then we have volatility, right? So, but in this volatility, we have two things, or two different aspects we expect from a fuel. So during a storage, fuel should not be volatile as much, but during the combustion, it should be very volatile. Volatile means very easily combust. Yeah, so that's why we need to actually take the fuel up to a certain temperature. For example, diesel engines need a higher temperature to operate. That is because their volatility is lower, right? Then we have a calorific value. A calorific value means how much of energy is stored in that fuel, right? Calorific value is a very important factor for us for like doing basic calculations. So higher calorific value means it's actually a better fuel, right? Next we have gum content, right? Gum means fuel started to actually make a polymer. So they react with other chemicals, other materials available, and start creating polymers. These are more or less like a gel sort of substance, which is actually not suitable for use in automotive fuel, because that could actually clog up the fuel systems, carburetors, or any of the components inside the vehicle. So because of that, gum content should be very low. And sulfur content. Sulfur means, sulfur is a element, and sulfur is an element available, or the chemical sulfur is actually available in some fuels. So having sulfur is good somewhat, right? If you have sulfur, uh, we, so, so if you have sulfur, so having sulfur again, right? Having sulfur, something wrong with internet. Hope all of you can hear me well, right? So having sulfur is somewhat problematic. The reason being, sulfur is actually increased in knocking and corrosion, but at the same time, sulfur actually increase the lubrication capabilities of a fuel. So in some cases, this is important. For example, fuel pumps. Fuel pump need lubrication, but fuel pumps can't use a separate lubrication system because they are actually working with fuel. It's difficult to use a separate fuel type. So what they do is they lubrication and cooling also done with the use of fuel. So in such case, this having sulfur is important, but having sulfur is problematic, increasing of corrosion as well as harmful emissions could generate. So because of that, at the moment, now less sulfur is actually understood better, right? So having less sulfur is actually always better. Next one is aromatic content. So aromatic content is important, mainly because we need to understand if fuel leak is going on, but aromatic content should be somewhat controlled. If not, if the aromatic content increase, what happened is this it will ended up creating a knocking, right? Knocking will actually increase by adding aromatic content. So to avoid this, it has to be a limited up to a certain level. So if you can remember, if you go to any fuel station, you can actually smell it, right? You can actually smell it. In some cases, these smells are not actually coming exactly from the fuel. It has to be added. For very good example is LP gas, right? LP gas is also coming as a, also it can be used as a fuel for automobile. The LP gas, the smell is not actually a natural characteristic of that fuel. That was an added chemical in order to generate that smell to avoid any leaks. That's why most of the fuel, even in the gasoline, that's actually help us to understand if there's a fuel leak. Yeah, so with once we discuss this one, so we have different fuels that we can actually use. So we usually divide them into conventional and alternative fuels. So at the moment we only discuss about the conventional fuels, but if you wish to you can actually learn about these alternative fuels in automobile technology. We have a special module called alternative fuels and combustion, alternative fuels and emission controlling, where you will be actually learning about how natural gas combustion works, liquefied natural gas, liquefied petroleum gas, also known as LPG, alcohol fuel, hydrogen, and biofuel. So all of these things, how the combustion works. But at the moment, we just going to discuss about the petrol and diesel. In some cases, like alcohol fuels and LPG, the combustion process is very much similar to gasoline, also known as petrol. So at the moment in world, if you consider the world, most popular fuel types are petrol and diesel. Petrol mostly used for passenger vehicles and diesel mostly used for commercial grade vehicles. In addition to that, in some countries, right, some countries liquefied petroleum gas or LPG and alcohol fuels and biofuels are very popular. For example, LPG. LPG is very much used in Japan, especially in the city vehicles such as taxis and city bus services, because their emission is far better comparing to any other type of fuel types. And biofuel is very much available in such countries such as USA or America. And alcohol fuels is mandatory in some countries, such having a certain amount of alcohol fuels in their normal petrol. So usually we call this as E85, M85, methanol or ethanol. These fuels are very much available in other countries, but at the moment in Sri Lanka it's not available. The problem with the biofuels, so the biofuels, somebody might think like, since we are agriculture based country, it's easy to make biofuels. It's not like that. The reason being is uh, bringing, or what calls, uh, if we consider the whole process of biofuel production and petrol or diesel production just using crude oil, right? The biofuel production is lot more inefficient. So because of that, biofuel using or production is not at good for country like Sri Lanka. Okay, so yeah, so we'll just discuss a little bit about petrol or gasoline. In petrol, we have it's again a mixture of hydrocarbons. If we consider the basic properties of the fuel is actually given in your left, right, left you have that, and in your right, it's actually giving what are the additives added into this fuel. So the fuel actually coming out from the refinement process is not the exact fuel that you used in the vehicle, right? That's not what you actually used in the vehicle. It has to be treated again in order to be used in the vehicle. So there are few additives included in these fuels. Let me just discuss about these. So first one is oxidation inhibitors to avoid oxidation and creating gum deposit generation. So as I told you earlier, gum means a sort of like a gel sort of substance generated in the fuel. So this is actually happened because of the oxidation process. To avoid these, certain chemicals or additives will be actually added into fuels. And rust inhibitors, so protect metal components from rusting, because the fuel is always in contact with the metal, either in the fuel tank or the fuel lines or the fuel pump or anywhere. So because of that, it needed certain additives in order to avoid rusting of the components. And we add tetraethyl add, right? This is actually added to increase the octane now, right? It's actually added to increase the octane number. Let's see, we'll discuss about the octane number. Octane number is actually representative how much resistive to the knocking, how much resistive to the knocking of a certain fuel. That's what octane number represents. So next we have a metal inhibitor. These agents are added to avoid reaction with metals in the fuel system. So we have aluminium, sometimes we have copper. Copper is very rarely, but we have aluminium. Steel is most common, and aluminium are the second most common fuel materials. And so to avoid having chemical reactions with them, we actually have to add metal inhibitor. In addition to that, detergent has to be added in order to keep the components clean, right? So detergents were added. All of these are actually chemical compounds, just a very small amount of chemical compounds added into the fuel to make the treated fuel. So so we added these to keep the components clear, like injector nozzles, carburetor, just for to be cleared for the best operation. Similarly for diesel also we have to add some additives, but as you can see clearly here, right, the additives are somewhat differ and added more additives. So fuel handling and distribution additives. The first one is low temperature operability additives, flow improvers, wax anti-setting improvers. Flow improvers means, if you can remember, diesel fuel is actually a little bit thicker oil. So it has very good characteristics similar to lubricant. So it's need to flow better in order to be used in the engines and to be easily transport. So you have to add flow improvements, wax anti-setting additives, cloud point depressants, de-icing additives, fuel stability additives. We have to actually add antioxidants, stabilizers, metal deactivators, same thing as before. So the first section actually discuss about how diesel fuel is actually working in the lower temperature areas, such as like countries such as Alaska. These guys actually have to have different setup in the vehicle in order to drive it. They actually, in most of these countries, even have a heaters situated inside the fuel tank in order to get the fuel up to temperature before the vehicle start, because otherwise the fuel flow and everything uh, will not operate properly. So in Sri Lanka these are not that much of a problem, because our temperature changes between the seasons. We can't even feel it. So because of that, it's not a big deal in Sri Lanka. But in countries like Alaska or any northern countries, actually have to be very concerned about this. Next we go, yeah, combustion additives, ignition improvers, smoke suppressants, combustion catalysis. Combustion catalysis helps the combustion. Ignition improvers actually provide the combustion process to start ignite faster. And smoke suppressants, one of the main problem. Even if you see a emission test report from a diesel vehicle, you will see they actually measure the opacity of the fuel, opacity of the exhaust from fuel, opacity of the exhaust. They actually measure the smoke amount, right? How much of smoke is actually coming from the tailpipe compared to the other. In the petrol engine, they measure different chemical compounds or chemical different outcomes. Like petrol, they measure carbon monoxide, carbon dioxide, and water. In here, in the diesel engines, they do not measure that, because they only measure how much of the diesel, sorry, how much of smoke is coming from. We call it as the K factor. So from the K factor only, they actually find out that the combustion is better or good or not. So, in addition to that, we have engine protective additives, corrosion inhibitors for vehicle fuel systems, and de-antigens and anti-foaming agents. Anti-foaming agents means when the fuel is actually moving left and right, when the vehicle moves, that means sloshing. We call it as sloshing. So, in such cases, when the fuel is actually sloshing, that could actually create like a foam by oxide going is oxide oxide, yeah, and what something like a foam actually generated, similar to, how do I explain it, similar to like a soap foams, something like that, right? That's the simplest explanation I can give. So to avoid that once the foam is actually created, it won't actually the fuel cannot be actually pumped. If it's changed into a foam, it's very much like a gas, so it cannot be pumped, so vehicle cannot operate. So same thing happens in the petrol. If you have higher temperature, it creates something called a vapor lock, somewhat like that. Situation is somewhat like that. So to reduce this foaming properties of the diesel fuel, detergent and anti-foaming agents has to be included. So combustion process, yeah, so combustion process, if we consider the combustion process, we will be discussing about this one separately. um, this is not in your curriculum, but I will just discuss how the process actually goes on, so for you guys to be a little bit more uh, knowledgeable on the matter. So basically, once you add the fuel into any combustion, you have hydrogen carbon. So hydrocarbons means hydrogen and carbon. So from the air we get oxygen, right? Then we combust. So in the combustion process, there's like two combustion processes happening. So basically, you have carbon and hydrogen combining with oxygen and making different outcomes. parts. So one is carbon plus oxygen. You have carbon dioxide and carbon plus oxygen again, but that time, the second time, same number of carbon atoms will be joined with same number of oxygen atoms. Then you have carbon monoxide. Similar, and in the water and oxygen and hydrogen, by joining oxygen and hydrogen, we get water. So water actually does not come as liquid water all the time. It comes as steam, which in some cases we can't see. So this is the actual process actually happening inside the combustion. Uh, it's not actually easy to just write a one single equation for the combustion process, because you need to understand this hydrocarbon, any fuel, it's not C2H6 or something. It's like C2H2, C2H3, C3H6s, different chemical. A lot of chemicals are actually mixed into generating a one fuel. So because of that, there are no particular chemical equation to represent the fuels. So that's why we actually discuss this somewhat like this. In addition to that, during the uh, sorry, during the incomplete combustion, right? During an incomplete combustion, since sulfur is available, we also get sulfur dioxide, which is actually not good for our health. Just don't be very much bothered about this. There's an example given here. It is taken octane combustion. So octane means C8, H18, C8 octane. Octane means octa. This octane actually comes from the C8 part. So octa, right? So octane. So octane plus oxygen once it balanced. The final outcome after complete combustion. If it is a complete combustion, you can get something like this. If it is a incomplete combustion, in addition to the CO2, you need to have another one saying CO, also known as carbon monoxide. Right. So minimum air requirement for a combustion can be calculated from the following equation. Don't yeah, you can actually calculate, but for now, please do not worry about this equation, because if you were supposed to worry about the equation, I will let you know. For now, don't bother about the equation. Just remember there's an equation like this. That's enough for you guys at the moment. Right. Next, we need to discuss about the calorific value. So calorific value is the amount of energy given by a complete combustion of 1 kilojoule per kilogram of fuel. So there are two calorific values. So we have higher calorific value and we have something called lower calorific value, right? So the higher calorific value, all fuels contain some hydrogen. During the combustion, a certain amount of heat is consumed for water and flue gas production, right? Including this in used energy, it's known as higher calorific value. So that means the energy used for generating the water also, right? Water and flue gas is actually known as higher calorific value, right? That's actually known as higher calorific value. Okay, give me 1 second, right? There's a phone call coming. Right. Yeah. So the higher calorific value. Yes, higher calorific value means all fuels contain hydrogen. So during hydrogen combustion, it's consumed certain amount of energy in order to produce the water and the flue gases. Flue gases means so in if we consider the previous example, we get carbon dioxide. If there's sulfur, it's produce sulfur dioxide. There's nitrogen, it can produce nitrogen oxide. So different types of fuel gases. So all of these gases we actually owe the additional products except for water vapor. So we all of these, once we combine all of these, we call it as flue gas. So this production of flue gas and water vapor, which actually also consumes certain amount of energy, right? So combining with that, we actually call it as the higher calorific value, right? Higher calorific value. So if we go to the the lower calorific value is actually the amount of energy produced excessive of energy consumed by the steam and the flue gas production is known as the higher lower calorific value. This should be lower calorific value. There's a mistake here. Please note there should be lower calorific value, right? So the if the oxygen is present, then it's assumed the whole amount is consumed by the hydrogen having mass equal 1/8 of oxygen, and this amount of oxygen should be subtracted, right? So this is how we usually get the higher calorific value. Just don't worry about this. You just need to know what is higher calorific value, what is lower calorific value, and how lower calorific value and how higher calorific value both are actually combined. So for example, it's given here lower calorific value is equal to higher calorific value minus heat of steam formed during the combustion. That means the steam and the so flue gas is not included here. The reason being the production of flue gas only consume a very small amount of energy comparing to the uh, uh, energy required to generate the steam. That's why it's not actually given here. So in order to find how the higher calorific value or lower calorific value from the higher calorific value, you just have to multiply hydrogen value into 2466 kilojoule per kilogram. That's the latent heat of vaporization of water, because in order to generate steam from water, you need this much of energy. I hope you guys can understand. Right, so we'll just move into the combustion process a little bit. So gasoline combustion, we have petrol combustion and diesel combustion. We discussed previously in your session in the unit I think unit 2. Yeah, unit 2, we discussed about how the fuel consumption combustion processes are different. For example, diesel, gasoline engine or petrol engines are known as SI engines, spark ignition engine, and the diesel engines are known as CI engines, compression ignition engine. So the energy or the heat released by the combustion process is actually a function, or it's actually depend on the calorific value of the fuel, mass fuel ratio, mass of charge, right? How much of air fuel mixture is in there, and what is the ratio between air and fuel, and what is the calorific value of the fuel. So all of these are high, that means you get more power. That's why vehicles have the larger vehicles actually produce more power compared to a smaller vehicle. Also, a smaller vehicle can produce a large power if you add something like a turbocharger, which is actually the turbocharger or supercharger. These are actually known as forced air induction system. So usually when the piston is moving up and down, right? When the move once the intake valve is open, when the piston is moving down, right, the air is actually sucked in by the lower pressure inside the combustion chamber, right? Inside the cylinder. That's how we usually get the air. But in the forced induction, so this process, the air coming inside the combustion chamber just by the movement or the pressure difference between the atmosphere and the inside of the combustion chamber or the cylinder is actually known as naturally aspiration of engines. So it actually draw air from the outside because of the pressure difference. But in order to increase the efficiency and produce more power, as this one suggests, you need to increase the mass of the charge. So how much I have put it in. So the good thing about the AI is it's very compressible, right? This very compressible. So once if we can compress more AI and we can put it in, that means we can get more power out of that. So that's why we have something called a forced AI induction. In the forced AI induction, we use turbochargers and superchargers to cram more air into the uh, cylinder, right? More air into the cylinder, that means more pressure inside the cylinder, that means more fuel has to be added, so we can actually get more power. So for a lower engine capacity, by adding a forced induction system, it increase the mass of charge. So how much of air actually going inside air fuel mixture. So in order to maintain the air fuel mixture ratio, you need to add more fuel, again more power. So the thing about these engines in the petrol engines is, if we can increase the uh, compression ratio, the efficiency of the engine actually increases, right? It increases the efficiency. But the disadvantage is, once we increase the compression ratio, it started to knock. The knocking characteristics also, or knocking tendency also increase, right? So higher compression ratio, increased thermal efficiency, more tendency to knock, but less tendency to knock at lower thermal efficiency, but engine is having lower compression ratio. That's why most of the new vehicles, right, new modern vehicles, they, if the manufacturer ask only, you have to put 95 octane petrol. That octane is the combustion or knock rating. So how much of 95 means, that is the knock rating. So it does not means you have 95% of octane in there. It's just a measurement used for knock rating. So with respect to something called octane value. So octane is actually chemical. It's measured respective to the octane. So there's a big process related to that. I'm not going to go through that. Just you need to understand is, if the vehicle is having a higher compression ratio, right? Manufacturer will actually inform to the owner that you have to use 95 octane fuel. So unless they have mentioned like that, there's no point of using 95 octane fuel in any vehicle, right? But most people do put 95 petrol, saying it's good. There's nothing like, it's just a waste of energy, waste of money. Actually, there's no point of putting unless the manufacturer asks you to do so. Right? It's just waste of money. Probably you will actually lose power by just putting 95 instead of 92, because that particular fuel 95 is a little bit more reluctant to combust, right? That's because of that. So so this knocking, once we go to the knocking is actually something called auto ignition. It's a process of auto ignition. Auto ignition is the natural phenomenon of oxidation reaction that initiate the progress because of the environmental condition. So that means combustion, because of the environmental combustion, the environmental conditions inside the combustion chamber is actually known as auto ignition. So auto ignition comes with two uh, processes. One is pre-ignition, other one is knocking. So pre-ignition is auto ignition that occurs before the spark goes off. So there's a particular time for the spark to go off. This is how it works. So if you consider now this graph, if you can see here, the piston, when the piston moves, once the inside the combustion chamber, highest pressure, right? Highest pressure should be reached when the cylinder or piston actually comes to the TDC position, right? So once the piston comes to the TDC position, at that moment, the piston inside the combustion chamber should generate the highest pressure possible in order to get the maximum work out from the engine. So in order to do so, the ignition has to be provided a little bit earlier, right? A little bit earlier, little bit earlier than that, in order for combustion to start, spark to provide combustion to start and generate the maximum pressure, right? So that takes around certain milliseconds, let's say 10 milliseconds. So 10 milliseconds should be, it should be given 10 milliseconds faster. So that means before the crankshaft or piston goes to the TDC position, spark had to be provided into the engine. So if in case this ignition for some reason, or there's a good lot of reasons for that, one good reason is too hot spark plugs. If the spark plug is too hot, so spark plug has to be cooled. They have certain we have some called hot plugs and cold plug. If you use a hot plug in a cold plug location, that will create a problem that will automatically ignites at a certain pressure. So it could actually ignite before the correct position. So the piston will not, or the combustion inside the combustion process, it will not reach the maximum pressure necessary. So it will generate a lot of less power. Now knock is a completely different. So knocking is the auto ignition that occurs after the spark has fired. So even after the spark is given, knocking can be generated. So if you can see here this graph, right? So ignition timing is over here just after 0 degrees. But if you can, if you clearly very well, if you watch it very well, if you look at this very well, very carefully actually, you should be able to see that knocking, this is the knocking, this is how the knocking, if you measure it as how the pressure changes, this is how it actually see, right? So this is how it actually see. So this is not what we actually need. This is not actually what we need. So this roughness, right? This roughness is actually came because of the knock, or because of the sudden detonations inside the combustion chamber. So these small detonations create a violent knocking characteristics. That's why it's actually came about, right? So this is not actually something we need. There are so many different ways we can actually fix this one. Is there's this process, this combustion process is very complicated, so I'm not actually going to go too much deep in there. But basically, you can just have a proper fuel propagation. So ignition timing can be checked. If there's any if there's so much carbon present, that could actually end up creating NOx. So different reasons, so these sort of reasons could actually create situations like this. So in the diesel combustion, somewhat different. So diesel engine is viscous and heavier, right? So it's actually more like a heavy oil. uh, but still this diesel engine also knocking, right? Knock happens. So this actually happens sudden ignition and rapid combustion of fuel, initially accumulated fuel. So this is mostly, yeah, this is mostly created by the fuel timing here, because in a diesel engine, even though diesel engine does not have a ignition system, diesel ignition actually generate, or ignition is actually uh, started, we can say started by just injection of fuel, right? Fuel is injected at the last moment possible. So if you can see here in this graph, right, in this graph, the TDC is over here. Just before the TDC only, fuel is started to injection. So if this fuel is not properly injected into the piston, that could actually create a that could actually create a knocking characteristic. One question was, there's a question, someone asked how to determine knocking. He said, that's what you asked, right? 1 second. How to determine the knocking in cars? I'm not getting, what do you mean by how to determine knocking? So if there's knocking, how do you know? That's what you asked, right? So yeah, if it is like a modern vehicle, if the engine started to knock, the vehicle try to fix it itself, because there's something called a knock sensor, which measures if the knocking is happening inside the engine. If that is not the case, if it is an older version, right, older versions like carbureted vehicle, so in such case engine could not actually measure that. In such case you can actually hear like a sort of like a violent explosion sounds inside the engine. It's out of the ordinary. So in the ordinary fashion the engine makes a sound, but there's something like off from that. So if so somewhat off sound is coming from the engine in some cases, and it's not rhythm, there's no rhythm in that, it's missing here and there. So that's how we actually identify if there's knocking is there, or otherwise there's a electronic equipment that we can actually use to use for this purpose, right? So in the diesel engine, if I come back, the same reason. So after the fuel injected, so fuel injection is where the ignition started to happen, right? So once the fuel injected, right, the pressure inside the combustion chamber rises even further. At a certain point, engine started to, inside the combustion chamber, it started to combust, right? But if this is not properly injected, so if there's any issues in the combustion, the injector, this could create accumulated fuel. So if there's too much fuel in a certain area, that could create certain like a violent outburst. So that would create something. And the other thing is, if the injection was too close to the ignition point, so that means if the ignition is very close to the uh, TBC position, that could also create a violent explosions. So in order to change these things, you can actually change the injection point. So in the diesel engine, this process is somewhat more complicated than a petrol engine, but basic idea is diesel and petrol is also knocking. The reason being how the fuel and ignition is delivered there, and in order to fix this, you just have to change them accordingly, right? So to fix this, for diesel engines, similar to the petrol engines, there's some rating. It's actually known as cetane number, right? Cetane number is higher for the fuels need to be used in higher compression diesel engines. Mostly for the modern engines, we call it as, you might have heard this, super diesel vehicles actually have a higher cetane value. The reason being, these diesel engines were designed to run at the optimum level in order to save the fuel and to be more efficient as possible. Right. Why do diesel engines do not need the spark to start the combustion? Okay, so you guys have to find the answers for this, because I already told two of the answers for these, and I expect these answers by the next class. Right. Next, we move into the first system, how the mechanicals or how the system actually works. So the purpose of the fuel system is to deliver the correct amount of fuel into the cylinders for combustion process while reducing the waste and emission, right? While reducing waste and emission, that's important. So emission, you already know, emission comes from the exhaust, right? But There are some other emissions actually also generated. Mostly these are actually sort of like a waste. If we, in our consideration, if we consider it in our general terms, it's usually called as waste, but it's actually a type of emission. One emission is filling emissions. Reducing the filling emissions, reducing the evaporative losses, and measuring the combustion quality. This is how we actually reduce the fuel wastage. So number one, if we consider about the filling losses, so the image number one, so if you can remember, uh, you might have seen this, when a vehicle is actually filling up, you can actually see the uh, fumes, like vaporized fuel is actually escaping from this hole over here in the filling cap, right? Filling cap is either the vaporized fuel is actually leaving. For petrol engine, this is for petrol fuel, this is more than diesel because it's not vaporizing that fast. So this vapor is actually leaving here. So that's actually wastage and it's actually an emission. Right? To how to fix this? One way to fix this is, if you can remember or if you look at a modern vehicle, the fuel filler cap is actually quite a bit small, right? Quite a bit smaller. And in addition to that, the very simple solution is to have this collar sort of thing on top of that, so the air or the vapor is actually not leaking out. And yeah, reducing evaporative losses. And the other thing is, once the fuel is actually put into the fuel, when we are actually moving, right? When we are actually moving, this fuel is sloshing left and right. That's again create a vapor or evaporate. The fuel started to evaporate. Even while the vehicle is parked, the fuel evaporate. So that fuel earlier it was actually used to vent outwards and to leave it to the environment. But now it's not like that. That vapor goes through something called evaporative emission canister, also known as a charcoal canister, and that from that it filters out the fuel and send it back to the combustion chamber in order to actually combust it, right? So it's not wasting anymore. And measuring the combustion quality, this comes in the emission controlling section. So one thing we do not consider about is emission. And in the previous years, like as I told you, in before 1970s, these emissions of fuel consumption, nothing was in, no one was read about these things. So those days, uh, no one care what's actually coming out from the emission. As long as vehicle is going, that's enough. So later, after found out that vehicles were causing all of these emission issues and everything, just if I give you the basics idea of here, this was actually happened 1950s in Los Angeles. So 1950s, 1960s, something like that. So you might have heard something called World War II. World War II, right? That's 1945, 44. This is finished. After that, America got or USA got a huge economic boost, and almost every one of them actually owned a vehicle. In America, vehicles were cheap. Still, is cheap, right? Compared to us, it's still is cheap, and people, almost everyone was driving. So there's no, most of the country, most of the areas in the country, there's no such thing as public transport. So you have personal vehicles. So in that country, 1960s, even 1960s, huge traffic jams were there and no emission controlling. The emission is actually coming, very bad, harmful emission is actually coming out from the tailpipe or the exhaust. So in 1950, I don't exactly remember the years, I think 60s or 70s, in Los Angeles town, it was actually covered with the fog, right? The authorities were unable to find what is the reason for this fog for few years, until they actually expected, because the fog actually comes from the factories emissions near the Los Angeles metropolitan area. But later they were able to understand it's not the reason, right? It is not the reason. The reason is vehicle, because almost everyone is using a separate vehicle for their own travel. So most of the time vehicle is traveling with the one passenger, right? So, and it's keep the emission is so bad, no emission controlling methods were there. So after finding this only, the world's then they started putting bans on vehicle manufacturers to reduce the emission, and now the emission controlling in California especially is very tough. They almost control anything. You can't even touch the vehicle emission system or any of the other things to that matter, for even like modifying is illegal there, right? So the reason is like that. So that emission controlling came and the fuel crisis came. After that, the fuel has to be changed, saved. So until these things actually occur, there was a lot of waste. So in order to find how much of fuel is actually, how the combustion process going and how the emission is, special method was occupied by the manufacturers in order to find out the combustion process, combustion quality. If the higher quality combustion happened inside the combustion, then emission is very good. If the lower the combustion quality, lower the higher the emission, harmful the emission is, right? So that's how it actually worked out. So somehow the emission controlling and everything combined into the fuel system, and now we have a very complicated, somewhat complicated fuel system. Okay, so once we go to the fuel system, there are two type of fuel systems available when it comes to the petrol fuel systems. So number one is carbureted fuel system. The number two is fuel injection system. So it's not saying electronic fuel injection. The reason being, electronic fuel injection may be the modern method, but fuel injection is not a very modern method. It was used for petrol and diesel, both engines, from like I don't know 1930 something like that. For a long time, this was being used for petrol and diesel, both type of engines. So mechanical fuel injection is also available, though it is very rare. The reason for not using the mechanical fuel injection for petrol engines is it's very complicated. The system is very complicated, maintenance is difficult, and there's a simpler method available as carburetor. So because of that, carburetor system got very popular as it is cheap and easy to work with. But the image shown in your right, the circuit shown in your right is actually a electronic fuel injection system. So we'll just move into the how the fuel system works. Okay, so before we go ahead and start, we need to talk about one more thing. Yeah, so what happens once we start the car, especially for a carburetor engine, this is important. The reason being, why someone is sending these index numbers, registration numbers? Right. So once you start the engine, that means we call it as cranking, right? We call it as cranking the engine. So we turn the key and we start cranking. The starter motor rotate. In turn, it will rotate the flywheel. Flywheel will rotate the crankshaft. Crankshaft will start the moving pistons and valves. So when this operation is actually happening, it causes the fuel pump to run and prime the fuel system, and then the vacuum from the piston, right? Vacuum, that means the negative pressure inside the combustion chamber or the piston or inside the cylinder act as also uh, create a negative pressure area near the carburetor currency was sucking fuel into the system. That's how we actually start the engine. Okay, so so in order for this to start, the fuel system has few components, but some of these components, even though you are using fuel injection system or a carburetor system, the parts are the same, but there are some difficult differences between the types, right? Main parts of any fuel system is the fuel tank, fuel pump, fuel lines, and fuel filters. For any of these models, which it doesn't matter which type of fuel type you are using, both of these fuel types, sorry, injection type or the carburetor type, both actually use all of these components. The only difference being is the fuel injection system, since it's running on a higher pressure system, the components are all of these components are designed to operate with a higher pressure, right? So I put some fuel system. If you would like to read more details about the fuel system, I actually add this link. You can go ahead and read about this. Is more related to the emission controlling, which we will not be covering that much at this stage. So fuel tanks, yes, uh, we'll start with the fuel tanks, obviously. So fuel tanks are either made of steel or plastics or something like a polymer materials at the moment. Most of the manufacturers have moved towards the polymer material because of ease of construction and the lightweightness of them. And in addition to that, in case of accidents, they won't rupture as easily as a fuel steel tank, right? So having segregation, so having tanks inside the combustion fuel tank is also important. That actually reduces the fuel sloshing around once the vehicle is turning and taking turns. The fuel actually move from one side to another, front to back. To reduce these, they actually have something like segregations, as you can see over here. These plastic sections over here actually support the fuel not to move here and there. So you will have fuel around the fuel pickup area at all times. So the location of the fuel tank is a very important factor that most people do not actually care about, but unfortunately it's very, very important. Um, the reason being, it should be in a location, should be a very secure location, because in case of accident it should not be rupture and the fuel should not be actually leaking out, uh, causing for a catastrophic issue later on, something like a fire or something. So fuel tanks are mostly situated near to the middle of the vehicle, uh, as much as possible. But in most of the cases they have to consider about the space availability, ease of filling, and safeguard in case of accident. If you can remember, like a lorry sort of something like a truck, Leyland buses and Leyland trucks, they have like a metal guard going around the fuel tank. That was a mandatory part they have to add in order to save the fuel tank, because in case of accident from a side impact, any vehicle could come and hit directly on the fuel tank. To avoid that, they have to have that metal casing around it. So in a normal situation, this fuel tank may not be causing that much of an issue. But if we move into something like a racing car, the situation is very much different. So in these vehicles, the fuel tank plays a huge role, and they do not have the space availability as much as in the other applications comparing to a normal passenger application. So in such cases, their fuel tank is very much different. So the one actually shown here, it's actually a racing fuel type tank. This is a little bit common type of racing fuel tank. It's you can see inside of that it's actually have something like a foam inside the fuel tank. The reason for having this foam in normal vehicles, we don't have this foam. The reason for having this fuel is so once we fill the fuel, right, it will actually absorb the fuel. It will actually absorb the fuel into these foams, right? It will expand, absorb and expand, right? Even if the vehicle was turned upside down, right? Even if the vehicle turned upside down, the fuel will not actually come out. Even there's a rupture or something, the fuel is not started to leak because it's actually absorbed by these foams. That's how fuel is actually stored in some racing. It depends on the racing class and how the regulations status there. But with all of these safeguards and everything, some things could go wrong. As the image shows in the bottom, this image actually shows a very fatal accident happened last year in Formula One. So one car actually flew out of the, I mean, slides out the wheel, out of the track and hit over here. And the car was actually, as you can see, it's broken in half, right? So two pieces, and the fuel tank actually ruptured. So fuel tank is situated in between the driver and the engine. So that's the only location they actually have. That's the safest location for them as well. But fuel tank actually ruptured, and the fuel started to leak, creating a huge uh, fire. But somehow the driver was able to get out because he's wearing a safety fire retardant suits and everything. But in a normal passenger cars, we will not be having any possibility of walking out of a accident like this. So in these cars, the fuel tank is even different from the one over here because they have something called a fuel bladder, not a fuel tank, something like a bag. It depends. So there's difference characteristic of the fuels given in different aspects. Okay. So next we move into the fuel pumps. So we have mechanical fuel pumps and we have electronic fuel pumps. So in a bike and a three-wheeler, the fuel is actually delivered to the through engines from the gravity fleet, but most of the passenger vehicles, since the fuel tank is located lower than the fuel engine, it has to be pumped up or it has to be lift up. So to do so, we use something called a fuel pump. So mechanical fuel pump is somewhat like this. It has two sort of like a chambers which actuated by the camshaft or the crankshaft. When it is actuated, it's actually run by a lobe in the cam or crankshaft, which then move this diaphragm up and down, creating the pumping effect over here, which also contains two one-way valves, and the fuel is actually delivered there. In the when the carburetor is completely full, this fuel will be actually returned. The pump will be running, but fuel will be returning back to the fuel tank. So these sort of fuel tanks, fuel pumps were used previously, like older generation vehicles, but later these were replaced by electric fuel pumps used in the as shown in the image above. So these comes in two different method. One is coming with the written one, and the other one, as shown here, is not actually comes with the written line. So these can be fixed in between the fuel tank and the um, carburetor. So, but disadvantage, these could not actually deliver higher pressure, right? They can't deliver higher pressure. They can only deliver very lower pressure, as shown here, 300 to 30 to 40 pounds per square inch. And some of these actually have an inbuilt pressure switch. If once carburetor float valve is completely closed, fuel will not be delivered into the float chamber. In such case, this will automatically switch off. Later, when the fuel is only needed, it will be provided in some kind of return line. So electronic fuel injection systems also use mostly electric fuel pumps, but in the modern fuel, very modern engines such as the gasoline direct injection or GDI engines, they actually use a mechanical fuel pump because they have two fuel pumps, one electric and one mechanical, because they are operating at a higher pressure ranges. So they actually have two different fuel pumps. So electronic fuel injection pump is, if we consider the most common or the most common version, which is not gasoline direct injection type. So in there you have uh, something like this. The arrangement is somewhat like this. This has a bucket sort of arrangement. Inside of that bucket, fuel pump is actually located, which can deliver up to around 40 to 50 bar of fuel pressure. This fuel pump is actually controlled by either through a return valve or with a, 1 second, I have phone call coming. Yeah, so yes, these fuel pumps actually you deliver around, so EFI fuel pumps around 40 to 50 bars, and they are located inside the fuel tank. The reason being, these fuel pumps is they are working higher pressures, they need to be cooled properly. So these are submerged in the fuel tank to be cooled using the fuel itself. So these fuel pumps actually being controlled using the either with the ECU with the pressure switch, or they also have a return line in the fuel system itself, which is actuated by a um, vacuum control system. Right? I'll explain that later. Just don't worry about it for now. So the fuel delivery system up to the carburetor is fuel is picked up from the fuel tank, and it will be delivered up to the carburetor through a mechanical or electric fuel pump until the carburetor. So carburetor is not a single component, this is a combination of components which deliver fuel into the combustion chamber, into the piston as or the cylinder, on the piston cylinder, based on the situation, how much. So it's try to keep the fuel as the best fuel at the best value as much as possible in order to control it very well. So basically inside of a carburetor we have these components, right? So I know you already have an idea how this actually works, right? So the this sort of arrangement is actually called as an updraft, because the air is actually sucked from the bottom and the air goes towards upward. So this is called as an updraft. So the fuel that comes up to the carburetor comes through here, this fuel inlet, and delivers up to the float chamber. So this is the float chamber. In the float chamber we have something called a needle and a floater here. So this floater uh, will actually have a small needle which will be closed once the fuel comes up to the correct uh, amount that it's need to operate. So uh, then we have something called this line. This is actually given in here. So the fuel is actually taken from here and delivered up to the this chamber here. This section, this narrow area is actually known as venturi. The reason for being these sections to be narrow is so the airflow, the speed of the airflow will be higher at this area. So once the airflow speed higher increases, the pressure will automatically drop. That allows the fuel from the tank or this float chamber to be delivered up to here. That's how it works. So how much of fuel goes into the system is actually controlled by this throttle valve, because the way how based on how it opens and closes, it changes the vacuum inside the intake manifold, right? It changes the vacuum inside the manifold, controlling the amount of fuel goes inside, right? So I'll explain this one a little bit better in the carburetor operation, where we discuss this section in 5 steps, right? We discuss this in 5 steps. So for any carburetor to operate, it has to have meet 5 operating conditions. One is starting, second one is idle and low speed, part throttle, and full throttle circuit, right? In addition to that, later there was another section added, something called an acceleration pump circuit. So acceleration pump. So starting circuit means how to start the vehicle. So during the start, if it is a cold morning, more fuel is actually needed, right? More fuel is actually needed. And idle means in order to keep the engine running at the lowest possible sustainable RPM, called at low idle speed. And part throttle means throttle is not fully open, half open, and fully throttle open. The problem here is, if you can notice here, so the fuel is actually delivered to this venturi over here, right? This venturi over here. The issue here is over here. So based on how much this throttle valve actually open, the vacuum inside is actually changed, right? Based on that, the fuel has to be controlled. So to do that, these engines, carburetors actually have 2 opening holes like this, right? 2 opening holes like this. So one hole is actually called as, so if you can see here, throttle never going to close completely. It's actually goes up to a like 5 degrees position, and it's moved like that. Right? Still air and fuel can go around it. So there's a small gap around it, right? So in a fuel system, the carburetor, you can see here. Okay, so what actually happens here, this idle port is where fuel is actually delivered, right? When the engine is starting, after the engine started, the fuel is delivered through idle port. If you can remember, if you can see here, you can see this is closed. So when the throttle is closed, the vacuum inside here is higher than the vacuum over here, right? So fuel is actually drawn from here and it goes up this way, and it's actually comes through here from the idle port. Once the idle this throttle valve is open around half, right? Let's say around this much, right? So now these both of these are actually in the same vacuum. The fuel is actually coming from this one now, right? That's spark throttle. Now fully throttle open means all of these actually have the same vacuum. So the fuel is actually delivered around here, right? More fuel is actually coming from here. Okay, so that's the full throttle situation. So in the acceleration, if you need to accelerate, there's another section called acceleration pump. So this is the acceleration pump. When you suddenly press the accelerator, there's a plunger, something like a piston, that pushes fuel into the venturi, additional fuel into the venturi in order to deliver a higher pickup speed, right? In addition to that, we have to start the engine before we do all of these things. So to do that, we have this choke valve. We have this choke valve. Once the choke valve is closed, right? So we have more vacuum inside of this thing, and more fuel will be actually coming through, opening the, giving more fuel for start, right? That's how the system works. Let me just try to explain this bit more easy. So starting, okay, this has to be closed. So starting this, actually this valve has to be closed down like that. So vacuum is created around here, right? Vacuum is created around here. More fuel is actually drawn here in order to start the engine. So this actually image is from something else. That's why it's shown like this. Uh, Next one is idling. So yes, as I told you earlier, now uh, the vacuum is actually here. The lowest pressure is around here because these two are somewhat closed. So the fuel comes here and goes through this jet. These are the metering jets, right? This is the jet. So this is comes as the uh, jet valve, and jet valve sends the fuel through here, right? Metering jet, and comes here, and it goes up to this line, and from there fuel comes here, right? Fuel comes here, and it goes through here. But since the vacuum, there's no vacuum here, the pressure around this point and this point is the same. So fuel is not trying to get out from there. Instead of fuel travel through this way, and it comes out from here. And very small amount of fuel is actually coming. And the screw that we all are turning to reduce the fuel consumption, that's this one. That's idle controller, right? Sorry, it's idle mixture control, right? So there's no point of actually controlling the rotating that. It will reduce the idling speed, but it will not reduce the fuel consumption of the engine, right? Next, before I go ahead, I need to point out something. So there's these components. You won't be seeing it in the other image. The reason being, this is actually a solenoid valve. So this is available in all of the carburetors. The reason for this is without this solenoid valve, the fuel will be always open. If you can actually push the vehicle hard enough, engine will automatically start with or without the heat. Right? To avoid that, assuming assuming the ignition system works, right? But to avoid, for better, or so as a secondary say fail safe system, this is actually there. So once you turn on the key, 12 volts will be provided into the solenoid valve. It will open this all over here for the fuel to be flown into uh, this section over here, for the fuel to be flown and fuel to be flow and supplied into the system, right? So that's why it's actually there. So over here you have the venturi. As usual, there's two venturis. This is the secondary. venturi, and this is the primary venturi. And in addition to that, you have a different components here. This is actually known as the mixturing screw. So actually mixturing rod, this is a mixturing rod. So there's a small components inside the carburetor which measure how much of fuel is actually being delivered into the engine, right? If we go to the next one, that's the idling. So idling means only the bottom valve delivering the fuel. Now if we go to the part throttle valve, so sorry, part throttle, sorry, comes back. At part throttle, the vacuum around here and over here both are same. So both of poles are actually providing fuel. So you have twice as more fuel coming. So engine can go a little bit faster, right? So a little bit faster. So that's why the fuel is coming up here. So next, if we go to the full throttle, see now the full valve is completely open, so there's no vacuum here, right? There's no vacuum here, but there's a vacuum here because there's a venturi, right? There's a venturi. So now fuel is actually coming from this way. Now the fuel is coming from this way. So these, all of these are actually different circuits. Since there's no pressure difference here and here, right? The fuel is actually not trying to come that way. Now fuel is only coming this way. Yeah, did you get that? So that's how this system actually works. Very simple. Actually, it's not simple as it seems. In order to make this, the complicated calculation and design has to be done. And if we consider the structure or the how to build the all of these circuits into the carburetor, that's also becomes a very complicated process. So anyway, so that's how the carburetor works. So there are like three types of carburetors available. Usually we call them as side draft, downdraft, and updraft, right? So the first image shown is actually a side draft carburetor, the second one is a downdraft carburetor, and the third one is the updraft carburetor. So if we consider which one is the first, it's the updraft carburetor. Updraft means it's actually suck the air from the bottom of the carburetor and supply it to the combustion and send it to the manifold. So there's no way to actually change the direction and fix it into some other thing, other way around. So you can't fix a side draft carburetor as a downdraft carburetor. Reason being the float chamber position angles are changing, right? This float chamber, you have to remember, float chamber plays a huge role in a vehicle. So there's a location it can be. The location has to be very much concerned about the float chambers because the vehicle has to be traveling on a certain angle, right? So it has to climb a hill. When it started to climb a hill, let me go back to the if this fuel, when the vehicle is trying, okay, we said vehicle is going downhill, so it's going from downhill. If the float chamber fuel goes like this, right, then the whole of the fuel will be sent through this air bleed line into here, right? So it will create a mess. So the location and how to fix this, how much fuel, everything has to be considered here, right? So it's not actually easy as you think. So that's why we have different type of different types of carburetors. In a way, that's why we have different type of carburetors. We'd say like that. So basically, the downdraft carburetors was invented first. The reason being, those days the carburetors, the machining accuracy. This is the, for example, the image shown here is actually from like a Ford Model T. So those days, vehicles manufacturing capabilities and machining capabilities were low, so the accuracy of the carburetors are very bad, right? So most of the time they actually drip more than necessary fuel into the system. To avoid that and create to avoid putting more fuel into the system and flooding it, they selected the updraft system. So if there's more fuel coming into the Venturi, then the only the necessary amount of fuel will be coming, will be sucked into the cylinders. The rest of the fuel will be actually dripped down. So that's why these updraft carburetors were invented. But later, the side draft carburetors and downdraft carburetors were invented. So basically, the reason being side draft carburetors mostly used for like high performance applications. The advantage being they can provide more control over each cylinder. So, for example, here, this one here, the same carburetor is used here. This is actually a Weber carburetor. We call this as Weber carburetors. So branded, it's a type of carburetor brand. So these Weber carburetors fixed here, it's actually side draft carburetors. So the by having four carburetors, it can deliver more fuel. So each cylinder can get more fuel. If you consider here, this one goes into V8 engine, right? So this is a V8 engine, four cylinders and per bank. So that means 8 cylinders. So there are four Venturis here, right? Four Venturis. So each Venturi is actually responsible for 2 cylinders, but there's no regulation saying that all two of them are getting the same amount of fuel. Same here, you have one single carburetor. Let's assume this is a four-cylinder engine. It's going for 4 cylinders, so there's no way telling that all 4 cylinders getting the same amount of fuel. So that's why these sort of carburetors for each cylinder, separate carburetor was fixed, but it was a very complicated system and tuning and everything also very difficult because there's different screws, different air bleeding systems. Everything has to be perfect in order for these to run. So this is not common. This one is very common method. This is not that common, and this also not that common. That means updraft and side draft is not common. But downdraft is very common. Here you can't actually see the downdraft carburetor from the air intake over here. So air filter here. So I'll just say the air filter or air intake system is also playing a huge role in a vehicle. I don't know whether you have noticed. Most of the sound from an engine actually comes from the air intake and the exhaust, right? Not from the components working inside the engine. They do not almost produce any noise. So having a air intake system like this, it actually do not muffle any of the noises that actually generate. But if you consider modern intake system, it has like a boxes, few boxes and a pipe with ribs and everything. So the reason being it actually muffled more noise and reduces the noise level inside the cabin, right? So having a open carburetor system like this, it actually looks cool and everything, but it's not the best way. Okay. So at the moment, carburetors are obsolete. No one is using carburetors unless like very cheap applications. Why is that? I need your answers. You have already done the practical and you know why is it not being used. Give me your answers. No answers. 74. Imasha or Imasha? Imasha. 74. Sahan. 72. Can you tell me why it's necessary or why carburetors are obsolete now? No answer.
Easy to repair.
Obsolete means not in use. So if it is easy to repair, will it be not in use?
Fuel efficiency is low.
Yes, fuel efficiency is low. What else?
The cost of maintenance is high.
Sorry?
The cost of maintenance is high.
Yes.
Carburetor.
Maintenance cost is higher. Yes. Anything else?
More power.
No, carburetors do not produce more power. It produces maximum the same as the EFI system.
Engine performance increase.
Yeah, so basically carburetors became obsolete because they can't control, they could not control the fuel well. So they can control the fuel.
Ideal error. Ideal errors.
Ideal errors mean ideal or idle error?
Idle errors.
Idle errors. Idle errors. Idle errors means idle RPM or something like that. I'm guessing something like that. Anyway, so yeah, the reason being carburetors, the reason for carburetors to be obsolete is carburetors are not efficient and they have to be constantly adjusted, need to be cleaned. There's so many issues with them, and the fuel controlling is not exact, so it could not control fuel very well. So the different type of carburetors was introduced, so also known as electronic carburetors. So let me try to explain this in a simple way, right? So you know how a computer works, right? You have a process, then you have output. In order to get the output, you need to give a input. Right? So this is how our normal computer works. Am I correct? So you give a input and process and output, right? Same thing for a car, right? So you provide fuel, right? Then you combust it, then you get power, right? Power and emission, right? Power goes somewhere else, and we don't know though whether our output is correct. This is the optimum output we can get. So there's no way to measure this, right? So this sort of process is actually called open process, right? So process is called as open loop process. The reason being is output has no control over input. Input has no control over output either. Yeah, but if we can get something, a feedback, if we can get a feedback, so if we can get a feedback, so this is something I'm going to use. So process output, from output we get a feedback, and that feedback is now controlling the input. Right now output is checked, and we get a feedback whether the combustion is good. Right, then we control the input based on that. So we have combustion is so bad, that means we got a feedback, okay, combustion too much fuel, so we reduce the amount of fuel. Right, so this sort of process, right, this sort of process is caused as a closed loop process. So the problem with the carburetor is it's missing this section. There's no feedback, there's no way for us to interfere and control it. Right, so that is the disadvantage of a carburetor. So because of that, right, the fuel, once we set it at a certain level, it's never changed. If there's any problem in the carburetor also, we don't know. So to fix that, the carburetors were included with the electronic control module. Right, electronic control module. Now, have you seen these sort of carburetors? Have you ever heard of these sort of carburetors? You might have not actually. I don't think you have heard these sort of carburetors. But if you can remember, the carburetor vehicles came after 1978, 79, they have a lot of vacuum lines and control different vacuum modules, like early 1980s, right? So those vehicles actually had a type of a carburetor similar to this, right? So these are actually known as electronic carburetors. What it does is, these are in between like electronic fuel injection and the normal carburetor method. They measure the exhaust, right? They measure the exhaust and control the fuel goes into the combustion chamber. So how do they do it? So very simple, right? What they do is they take inputs from different components of the uh, different parameters of the engine. So for example, it takes engine temperature, right, coolant temperature, throttle input, exhaust quality. Basically you need all of these three. Then based on that they control air fuel mixture. So in order to control the air fuel mixture, the problem here is the air fuel mixture is basically controlled by how much of vacuum generated inside the combustion chamber, inside the carburetor. So to control this air fuel mixture, they actually control using another valve to control the vacuum, right? They control the vacuum inside the manifold. So this was a very common method used in like 1980s. The vehicles such as yeah, something like Toyota Carina, like 1980s Carinas, these Coronas, all these cars, and even the Bluebirds, all of these actually have this module, right? They actually have this module. I might actually have one. So even my car, the one I am using currently, that also had one. I removed it. The reason, those days nobody know how to fix it, because it was, even though there's a electronic control module, that electronic control module actually do not control the uh, carburetor directly. Instead of it actually opens and closes a set of vacuum valves in order to control separate valves and doors and in order to control separate actuators inside the carburetor, right? So that system is very complicated, even difficult to work with, even harder to work with than the carburetor itself. And without the proper knowledge and proper tools, with the proper values, vacuum gauges and everything, there's no way any mechanic could work with. So the system worked actually, the emission controlling for those states, it actually worked. But unfortunately, our people's knowledge and everything was not enough to manage them, right? So as a result of that, these sort of carburetors at the moment, as far as I know, almost none is actually remaining, right? Almost none remain. So I might actually have some components. Yeah, I'll show you once you come to the faculty. I can show some of these components. So this is like a very primitive setup of the electronic fuel injection system, but because of the cost parameters and cost parameters and uh, what you call these technical limits available those days, they had to go with these sort of arrangement. But later on, they were actually be able to fix this with the electronic fuel injection system, right? So then only the fuel injection system was replaced. But main thing you have to understand is fuel injection system is not a modern system. It was there for like even before the electronic fuel injection system developed, the fuel injection system was available. The one shown here on your right is a mechanical fuel injection system vehicle, right? These are also very complicated to work with unless you do not have the proper knowledge. They are very almost difficult, almost impossible to work with, right? If you can see over here, this component here, somewhat similar to a distributor. So this is the fuel distributor. In addition to the ignition distributors, spark distributors, you also have something called fuel distributors in these, right? So this is the fuel distributor, right? So what it does is it's actually distributed the fuel necessary amount into the each piston, and to measure this amount of fuel needs to go, they have this particular attachment here. It's like a, again, more like a vacuum sensor sort of arrangement. It's a bit complicated. We're not going to follow this one because this is almost not possible to find in Sri Lanka. Also, this mechanical fuel injection system was available in like early Jaguars, European vehicles, and especially if you might have seen Volkswagen Beetle, there's something called Super Beetle. So Super Beetle means 1300cc engine. In 1300cc engines also there's something called 1303 Beetle. So that one actually has a fuel injection engine. Because of all of these difficulties, it was later replaced with this electronically fuel injection system, right? Electrical fuel injection system. I will give you a brief introduction to the fuel injection system at here. Then we will discuss about the fuel injection system. I will be uh, with more detail later on. So basically, how it works is you have a fuel supply, so that means fuel tank. Fuel tank, you have a high pressure fuel pump. This is usually actuated, or this is a electric fuel pump, right? It could be mechanical but mostly electrical. So electric fuel pump fuel at around 40 bars of pressure and send it through a fuel filter into a something called a fuel rail. So it's a common rail of fuel, right? So it's a sort of like a cylinder sort of arrangement which is filled with fuel. Yeah, it's filled with fuel, right? So to this fuel rail, you have, if it is a 4-cylinder engine, each cylinder has a different injector. So these are electronic injectors where it will be only be actuated with the electric signal, right? These can be switched off and switched on based on an electric signal, right? So assume that fuel actually comes in around 30 bars, right? We assume that it comes at 30 bars. So 30 bars of fuel is delivered in here, right? So in order to control the amount of fuel, what injector does is it control the injector opening and closing times, right? It can control its opening and closing time. It can kept it open for longer time or a shorter period, right? Longer time or a shorter period. So based on that, amount of fuel actually goes inside actually changes, right? Actually changes. So when one of these actually open, right? Once this one of these valves open, the fuel pressure automatically changes, right? It's not good. At that time, fuel regulator over here act as an this component here act as a fuel regulator, which sends the in it actually measures how much of vacuum in the manifold. Based on that vacuum, this actually regulates the fuel at the necessary value for that particular instant. And if it is getting more fuel than that, it will cut and it will return the fuel back to the fuel tank, right? So this fuel injector, in order to operate this, the timing and everything actually depends on until this everything is automated, right? There's nothing is measured up to here in the basic version of a fuel injection system. Nothing is measured until here. It's all mechanical until up to the fuel rail, the pressure regulator, everything all mechanical. No electronic interference to any of these things, right? So in order to actually control these fuel injectors to be efficiently controlled, there's a control module. So control module has a connection, a separate connection to each one of these injectors. So it can either one, so these can be operated individually. So to control them, it takes everything. It considers everything, even air intake temperature, how much of air goes into the how much of air is delivered into the combustion chamber, right? What is the how is the combustion at the moment from the tailpipe, right? So that means exhaust, right? What is the oil temperature? What is the coolant temperature, right? What is the throttle position sensor? The throttle position sensor gives the idea how much of load we are asking, so how much of power we are asking. Intake air measurements give how much of air actually goes into the engine, right? Coolant temperature gives an idea to this unit whether more fuel has to be given in a case if the engine is running at a lower temperature, so to bring the engine up to higher temperature, right? Also, if the engine is running at a higher temperature, there's instances this is actually providing more fuel into the system to cool down the system, right? There are some situation like this that we will discuss about this one later on, right? So basically it considers the input from the various parameters of the engines, and based on that it provided fuel into the fuel injection system. So fuel will be injected into the cylinder at correct times at correct amount by controlling each injector, right? These are not the only sensors necessary. There are more sensors than that, especially crank and camshaft sensors are necessary in order to find out the TDC positions to deliver fuel exactly. So which is preferable fuel system? So basically fuel injection system, actually electronic fuel injection system is the most preferable as it is very versatile and be controlled, and less maintenance comes with it. So because of that, mostly electronic fuel injection system is now preferred, right? So now we have to start diesel fuel system. So I will give you like 10 minutes. If you wish to go and have like a water glass or something, you can come back. I will start in 10 minutes. I will try to find something and I will share with you. But until then, I hope you did understand what I told you. Anyway, the idea here is fuel metering is done. At least if you can get the idea that fuel metering is actually happening inside of this element, that's enough for now. Once you come to the faculty, I'll try to explain it with the actual element. So the difference between the, as I told you earlier, difference between the multi-element pump and the single element pump is, in the multi-element pump, you have different element. In the single element pump, you only have one element, right? You have only one element. That's also using a pump like this. This is actually drive shaft, and it's rotate and deliver the fuel. So this one actually has a very different approach, but basically the operation wise it's same. I know this is not the most clearest image, but let me try to explain as much as possible. Okay, so fuel comes here, right? Again, this is also filled with fuel. Inside of that, there's like two sections. One section is over here where it actually has a rotary pump which pump the fuel from the fuel tank into the injector pump, right? So this section is actually the injection part. This section only the fuel pump section, right? So this, they pump the fuel into the injection part from here to here, right? I hope you get that. Then the fuel comes to this area here. So this area here, right? Your metering and everything is actually done by section here. Let me clear. Yeah, this is the plunger section, right? Plunger section. If you can see here, this is called a rotary cam. This is a rotary cam. It is looks like a sort of like a wheel with how do I say this? Something like that, right? I'll try to. I don't know whether you know rotary cam. Anyway, so this is a rotary cam. When the pump is rotating, rotary cam is also rotating. When rotary cam is rotating, it actually it's connected to this metering rod and the plunger, which both are at one. So the fuel is filled here, this section over here, and the fuel will be pressurized, right? Since this cam is actually rotating, once the fuel is pressurized up to the correct, once it rotates to the correct timing, the fuel will be actually delivered through the correct outlet up to the injector. I think you got the basic idea, at least for now. I'm actually not going to go through this again and again. I know it's not that clear, right? So I will try to find a more detailed video or something that I can explain this better. So one thing we did not discuss is engine speed controlling. So that's how the fuel controlling. In the engine speed controlling, the problem with the diesel engine is, so if we put the accelerator at a certain speed, let's say we press our accelerator pedal up to 30% the whole travel. So now after pressing a 30%, assume the the engine should be rotating at 2000 rpm. But the diesel engine, because how the fuel and everything and the inertia of the diesel engine, it actually tend to continue speeding up. So 2000 next, 2100, 2200, 2300, likewise it will keep increasing, right? That's a problem in the diesel engine, not like a petrol engine. Petrol engine, if you put accelerator at a certain amount, it won't accelerate, it won't change the, or it will go down, it will not go beyond that speed. But in the diesel engine, it will continue to speed up. That is a problem. So to control that, we have the governor, right? So governor, so I told you there's a governor in this hand, and we have our pedal here. So we press the pedal over here, but engine has to go up to 2000 rpm, but it tries to go 2100. As soon as it goes 1100, this governor interferes and it push it back and control reduce the fuel, right? Then engine rpm again drops. Once it drops, the governor again let it go. This will come back to its original position, increase the fuel, and it goes 3000. Beyond, as soon as it's increased 3000, again plunger puts back, right? So this actually happens all the time, right? It actually happening goes on happening, and control the vehicle's speed, right? So this is how diesel engines actually uh, keep its rpm at a level. But if you do not have the governor, diesel engines will increase rpm and destroy itself. To avoid that, we need to actually use this governor, right? So governors could come in different methods. There are mechanical governors, there's electronic governors, there's hydraulic governors, there's pneumatic governors. Different type of governors are there, but basic idea of the governor is the same. The governor is actually used in another vehicle you might have heard of, the steam engine. So governor is known as the world's first control system used by any machine. So machines use something called a control system. Nowadays control system has been so advanced. Its control system is very advanced. Now if you consider like a flight, something like a passenger airliner, they can actually ride by or fly by itself, even land by itself, right? Not now, it's actually happened in 1970s. The reason is the controlling system is that much improved. To be honest, vehicles nowadays, vehicle can actually drive alone. They can drive alone if we can let them drive alone. Only problem is the environmental effects or environmental everything around it also act. Everything else is changing so vividly, right? Within a very small period, everything around the vehicle change. So for all of these dramatic changes, we could not give all the instruction so far. We could not give all these instructions so far. That's why vehicles are not driving alone, but flights are, even uh, flights, even if you consider the 1967 or something, 69, right? People went to moon. That those days we didn't have the power of the computer that they used is big as much as a house, but the power is less than a calculator. But they were able to completely control the whole rocket to go up to the moon and come back. But still we could not control the vehicle to go alone in a road, because everything around is actually changing all the time. That's why we could not actually make it. Vehicles could not we can't let vehicles drive alone. Still, it's delivery is updating. Even though if you consider about this Tesla system, it's not 100% automated driving system. They what they do is change by monitoring how the drivers react to different situations, right? So I don't know whether you know about these Tesla vehicles. You have like a data link between the Tesla company. What they do is they measure everything. They measure everything of situations what we do, and all these decisions they will also measure, and based on that they are developing a AI system to drive the vehicle. That's all their whole idea or whole system actually works. Anyway, that's some additional information about the control system. So the basic of the control system still in use and introduced for the steam engine. Steam engine and diesel engines are quite similar, right? Low RPMs, need big, very like high strokes. So in that way, very much similar. And operation wise, both of these engines keep acceleration, it won't stop at a certain RPM. So both of them actually need a governor, right? Uh, so governors have limiting speed governors and variable speed governors, but in vehicles we need to actually use variable speed governors based on the speed of the vehicle. So basic governor attachment as is actually shown here, right? So if you can see here, this is your plunger. So I don't know whether you can see me. So this is your plunger, and this is our accelerator. Oh, this is the fuel control rod. Fuel control rod is here, then it is attached to a governor. This is the governor. So this one actually rotates. When this is rotating, it's shown here. When this is actually rotating, when the speed increases, these two weights tend to move outward. The reason being the centrifugal force that in turns push this plunger arrangement here, this sleeve, to its left, moving the arm here. That arm is actually connected to the uh, to the this arm is actually connected to the fuel control rod. So it will automatically close the fuel line, right? So the another basic variation of that is actually shown here. This is the most well, we can say like the most primary example of a governor, right? This is the most primary example of a governor. So governor is connected to a attachment here. So this is the fuel control line. You might be thinking why this fuel control line is actually on top of the engine. The reason being, so even though we have an injector pump separately, once we increase the capacity of the engine, like large engines, even like prime mover sort of heavy vehicle engines, they do not actually need to have a separate injector. Instead of what they do is they have elements, these elements, injector elements, fixed into the fixed on top of this camshaft, with the camshaft in the engine block O head. Usually it's a heavy engine. Engine block O head, it's fixed as separate separate element for separate cylinders near to the cylinder itself. We don't need to use a separate casing for these engines. So that's why it's actually have this long rod running with this. This is actually comes under that type of a engine. Again, this is another another image that actually showing the working of the governor. You can actually see the governor movement and how the low speed and high speed, how the governor's movement changing. Okay, so fuel injector. Fuel injector is a sort of like a needle. Yeah. So it's actually a steel components which can withstand high pressure and a very small opening at the end. Uh, it sits on the engine head where it will be actually delivering the fuel into the cylinder. So it's actually spring loaded. So you can see over here it's actually spring loaded, right? So this arrangement is very much the one. This is called as a unit injector. Unit injector being the plunger and everything is actually fixed inside the injector. So this is the one I was actually talking about previously in this one, right? So this is unit injector system. So this is that sort of injector, but basically the bottom half of this is very much is the same as a normal injector. So what it actually has a spring over here and a spring over here, right? So this spring, once the fuel actually delivered up to here, sorry. So once the spring, 1 second, how to move this? Once the pressurized fuel comes up to here, right? Once the pressurized fuel comes up to here, this conical shaped needle valve, right? Needle valve, the pressure act on this needle valve and pushed it upwards, right? Pushed it upwards against the spring force, and the fuel, the high pressure fuel, actually comes through this hole, right? And start spraying. That's how the fuel injector works. And a small amount of injector fuel actually goes through these, right? Through these, lubricating all of these moving parts. And you can see why it's actually need lubrication, since it is a metal body, metal surface inside of a metal surface, sliding up and down. So it creates friction and creates, and we are out to reduce that. It's need lubrication and cooling. So to provide that, fuel actually supplied through a small hole here as a leaked fuel coming out from there. It won't actually go easily. It actually has to come through this way. So once this valve open, only fuel actually flow through this. Okay. Yeah, for diesel engines, we actually have a direct injection chamber and indirect injection chamber. So the difference between direct and indirect injection chambers are, direct injection chamber, the fuel is directly injected into the on top of the piston itself. In the indirect combustion chamber, let me see, yes, fuel is injected into a separate chamber over here. So this is indirect, this is direct, right? So difference being, this one allow the combustion to start here and move this way. Here the combustion start inside the piston. So this can actually reach higher pressure. This is understandably more smoothing. Indirect injection, this is direct injection process, which is which can produce more power. This need more fuel, this need less fuel compared, because the combustion chamber is large, right? So at the moment, direct injection is popular. Most people try to use direct injection as much as possible. Previously, indirect injection was used especially in mechanical fuel injection, because the difficulty of controlling the fuel amount 100 very accurately. So indirect fuel injection was used, but now direct injection become popular with the electronic fuel injection system. So it goes without saying, diesel engines also have electronic fuel injection system nowadays. So yes, so indirect fuel injection chamber is used in lower light vehicles and light trucks. Because of this fuel injection controlling difficulties in the direct injection fuel system, this was used for indirect injection system was used as it's easy to control the emissions. Later on, this issue was fixed with the new system. So yeah, so someone is walking around with the phone in their hand and they don't even know the camera is on. Anyway, so the direct injection system operated at very high temperatures around 30,000 psi, because you have to understand the fuel has to be injected into like 600 psi combustion chamber, pressurized combustion chamber, and it has to be atomized as soon as possible. So it has to be pressurized in a higher value. So next we have the common rail fuel diesel fuel system, right? So uh, okay, so this is actually the same system as diesel electronic fuel system with a small bit of a difference. So if we go, I'm not going to go through this one again because same thing. Basically, it also have the timing control. Timing control system. If you go here, I can easily explain this. Okay, so you actually have the same unit, right? Same unit with actuating in a very higher pressure value. So the engine is actually controlled by ECU, which actually takes the engine speed, throttle position, or not the throttle position, actually in this case amount of load we put on the engine, and everything such as that, the engine temperature, coolant temperature, and everything, the ECU. Then the fuel tank, from the fuel tank, fuel pushed through the fuel filter through a feed pump. Fuel, this is a fuel feed pump, right? The fuel feed pump goes through, right? Goes through a pressure regulating valve. This is an electronic pressure controlling module that controls the fuel pressure, then send it to a high pressure pump. This is a mechanical pump. So the electric pump, it's quite difficult to obtain like 30,000 psi pressure from an electric pump. That's why these are using a high pressure mechanical pump to deliver very high pressures up to the distribution rail, right? This is known as the common rail. The reason for calling this as the common rail is this one, right? So it actually has a fuel pressure sensor fixed into this, which sends the it sends the signal to the ECU that controls the fuel pressure control valve here, right? Pressure control valve here, right? Then ECU also have separate connections for each injector, right? Separate connections for each injector. And still you can see there's a return line, still there's return line. The reason being, still you need to lubricate the return. That's why it's actually still having these return lines or the leak down lines. Okay, so ECU, after measuring all of these values, it's determined how much of fuel has to be delivered into the injector. Sorry, how much of deliver has to be done in each injector at each time. So fuel will be goes through this injector, it will open and it will comes through the piston. Okay, so same way everything is same, but here the injector actuation is somewhat different. As says here, these actually use a solenoid system or piezoelectric figure actually. So what they do is, once the pressure If it reaches the maximum pressure, it will automatically understand pressure is reached and the ECU control the piezoelectric valve. So somewhat different because these are made to run with or made to operate within higher pressures. Okay, so basically the same idea. You have the fuel and the each injector can be controlled with the timing based on the input from all the other parameters of the engine. So only different is actually this section where you have actually not only except for the injectors, you have a pressure limiters system here and the pressure sensor here and high pressure pump over here, right? But you have to understand now with the modern systems, nowadays, most of the manufacturers, even petrol engines, also have direct injection, gasoline direct injection. These are known as diesel direct injection system. Those are known as gasoline direct injection system, GDI engines, right? So these those GDI engines. So once you come up with the diesel GDI engines, there are like two different GDI engines. There were the GDI engines came even before 2000, year 2000. Those people say them they are not good. I don't know. It depends, right? But that GDI system and the new GDI system is quite different. I will explain them a bit later on your class. But anyways, so hopefully you understand up to here. But basically you have to understand is nowadays with the direct injection system, both of these fuel injection systems are quite similar to each other, right? Quite similar to each other operation wise, quite similar to each other except for the except for the fuel sorry ignition spark plug in the petrol engine, right? So I will explain that one in the next class. So from here I will be stopping this session, right? So this is your unit number 3. Okay, so this is your unit number 3. You only have 7 units, and with this I think we are only behind 2 hours, so we only have to catch up 2 hours, then we are actually uh, running according to timetable. So we were behind for a few hours, now with today around 3-4 hours, something like that. So with that we were able to actually catch up. So within one or 2 weeks we will be able to catch up. So the section we didn't cover from the unit 2, right? The section we stopped, wait once again.